Hi all, this is Anandaganesh Balakrishnan. I'm working as a principal software engineer at American Water. Welcome everyone to PlatformCon 2024. In this session, I'll be going over multi-engine data platform architecture for data virtualization. Here's today's agenda. I'll be going over data platform trends, how organizations typically set up a data architecture, what are the different challenges associated with it, what is a typical data maturity path of an organization, how data virtualization comes to the rescue and address some of the challenges associated with the traditional architecture, what are the benefits of data virtualization. I'll be delving into a novel data virtualization framework, what are the key components and benefits of the framework, and I'll be concluding the session with future research and directions. As far as the data platforms trend go, the landscape of data management is rapidly evolving with significant strides in AI integration, enhanced data governance, where compliance, data quality, privacy, and security plays a key role as AI is being used across use cases within the organization. And organizations are moving from on-prem setup to cloud increasingly on a day-to-day basis. And a lot of adoption is happening on the open table formats like Iceberg, Apache Hudi, and Delta Lake. And data products are being given a lot of emphasis in driving data driven decision making. So, the traditional data architecture setup in any organization comprises of like either ELT or ETL paradigm, and depending upon how data is being processed as a batch or via streams. Either it follows like a Lambda architecture, which comprises of both batch and stream, or a Kappa architecture, which comprises only of mainly of stream. And these days, organizations are using lake house architecture or Delta Lake architecture, where like acid properties are maintained, as well as it gives us the ability to do like time travel, to view the snapshots, to have like see the data as like as a scenario. And the another architecture which is being used is medallion architecture, where there are like having three layers like bronze, silver, and gold, where data is consumed from the gold layer. So the architecture falls and uses either one of or many of the paradigms which has been discussed here. Data is typically pulled from different data sources into a staging layer where the raw data has been kept, and necessary business rules and transformation rules are being applied, and data gets stored. And from there on, a model is being built for either star schema or snowflake schema, or like one big table in the analytics layer for the users to consume. The typical challenges that are associated with the traditional data management include data duplication. As data is moved from the data source to different layers, it incurs some storage costs, and data freshness, as increasingly organizations need data at real time because of the different stages involved and processing involved. There's a latencies which is always associated with the data movement. And these days, people are also facing issues with this vendor lock-in and the complexity associated with different data architectures like Lambda and Kappa, different stages and different data flow involved in it. And as a result of this, and the architecture, like as a maintenance that is involved with respect to the orchestration of different data workflows. And since because of the complexity of the data architecture, data governance is needed For example, to handle like PIA information across the layers. So these are some of the challenges which are associated with the traditional data management. So as organizations evolve, their data strategies mature from integrating multiple data sources to providing real-time data access through advanced visualization techniques, offering a consolidated and logical view of their data sets. So a typical data platform's maturity path moves from setting up basic foundational components for the architecture to creating a solid architecture for advanced analytics and machine learning to having a established data governance framework for having a reliable data and employing quality control techniques and having greater data accuracy to developing world-class data products to enable data-driven decision making to having data observability in place for monitoring and tracking the data workflows and to have anomaly detection resolution workflow in place and to have data flow optimization. So in data virtualization, data is integrated from multiple data sources through query federation, where data source can be files, database, S3 buckets, unstructured data, streaming pipeline. And this data abstraction happens at the data virtualization layer through business views, where all the business views contains joins of different data sources. And during the query federation, predicate pushdown happens and maximum filters happen at the data source level. And there will be a minimal data movement into the data visualization layer. And from the data virtualization layer, the client applications, BI tools like Tableau, Looker, connect and get the desired data. So it's a consolidated view, and clients and consumers will be able to have real-time data access as a result of data virtualization. So the typical four layers of any data virtualization architecture includes data sources, where it can be SQL database or AWS RDS, files, or log streaming, or any business application. And there's a logical data management layer where the business views are being created, where it has like MPP component or auto scaling component and query optimizer for federated queries and analytics engine. And there's a data governance layer to either to encrypt data or have to have role-based access control and to have data masking policies for PI, data labeling, and finally a data consumer layer where the BA tools like QuickSight, Tableau, or any client application which consumes data from. So some of the benefits of data virtualization includes reduced data redundancy as data is not moved from the data source entirely to staging layer like in traditional data architecture. And through the virtualization, the consumers will be able to have this real-time data access. And there's a lower IT overhead as a result of predicate pushdown. And data has been abstracted through the business views at the virtualization layer. And there's improved data quality and governance as a result of not many layers or stages associated with the data movement. And there's an increased scalability due to the MPP component. And since the data is not moved, there's a simplified data management. And for data visualization really helps in real-time data analytics and machine learning. As a result of that, the cost efficient pattern is evolved over here. And there is support for different diverse data sources. Since data is accessed real time, data products can be created in a quicker manner. And data catalog can be created for federated data efficiently. Some of the challenges associated with current virtualization platform includes performance and scalability for large data sets. And in terms of like complex queries, some of the optimization which is happening in the virtualizations may not be up to the mark. And there's like high resource utilization, especially for processing large data sets. And some of the virtualization platform are having like issues with the cloud integration, and there's a possibility of vendor lock-in as well. Let's take a look at this novel data virtualization framework where the federated queries are pushed down to the data sources, and the business views are created for data abstraction. And in this architecture, there's a possibility to have like multiple MPP engines based upon like open source MPP engines, and there is a possibility for having multiple caching databases and vector databases for doing for AI and machine learning purposes. So the consumers will consume data from the virtualization layer where data has been abstracted, and whenever the user query a view, any of the components can be utilized to fasten up the query response. Depending upon the data sets, the complexity and size of the data set, a particular MPP engine can be selected. And if the result of the queries which is being queried by the users is already there in the caching database, so those databases can be utilized to pull the data quickly instead of federating data to the different data sources. And for any AI application or LLM application, the better databases can be utilized. So this novel framework can be implemented like in three phases, where the first phase where we can have data virtualization with basic components, and then in phase two, it's augmented with MPP caching and vector databases. And phase three, where it has this data virtualization maturity with like adaptive query optimization, where depending upon the user queries, a particular MPP engine can be selected with enhanced caching mechanisms based upon the caching databases and its benefits. And the security and privacy can be enhanced in this phase three. And there should be frameworks for integrating with emerging technologies. So one of the key component of the novel virtualization framework is the MPP component, where MPP will help in scalability and performance with effective resource utilization while handling large volumes of data. And as a result, this enables real-time analytics as well. So MPP architectures with their parallel processing capabilities are essential for organizations to enhance their data processing and analytical frameworks, particularly in the context of large-scale and real-time data environments. And some of the MPP open source MPP frameworks are Spark, Trino, Presto, and Greenplum database. Some of the open source caching databases can be used, which is essential in data virtualization for improving data access speed, reducing server load, and enhancing overall system performance. So by serving data from cache, the load on the original servers is reduced, conserving bandwidth and freeing up server resources. So this contributes to better scalability and reliability of the system. So some of the open source databases are Redis, Memcached, and Apache Ignite, which can be used. The integration of vector DB is a game-changing in a sense because it enables real-time machine learning capabilities. So in data virtualization, vector databases facilitate rapid searches and retrieval of similar vectors using similarity metrics like cosine or Euclidean distance. So machine learning models can efficiently perform complex queries involving semantic understanding across vast data sets. So some of the open source vector DBs that can be utilized for this framework are Milvus, Pinecone, and VV8. Typically, vector embeddings, which happens along with the vector database, be it images, documents, audio, or video, goes through the models, and then the embeddings are getting created, which is stored in vector databases, and it will be used for any users with the queries or with prompt. uh, can be used for similarity search, where relevant contextual information is retrieved from the vector database and it's passed on to the LLMs to have a comprehensive response to the user and the correct response to the user. So the advantages of having this open source components are like it's cost effective, and it's highly customizable, and it has that flexibility, and there's a huge community support and innovation which is happening in the open source space, and it avoids vendor lock-in risks, and the databases which we have discussed is highly scalable and highly integrable. Some of the key benefits of this framework are like it harnesses the strengths of various data platforms, thereby addressing the limitations of the current data virtualization platforms. And there's a robust fault tolerance and high availability across diverse operational environments as a result of it. And high quality data products can be created out of it, which is beneficial for the consumers as a whole. So some of the future research and directions involved with this framework are adaptive query optimization based upon the use complexity of the query and complexity of the data sets. A particular MPV platform and caching database can be chosen. And still, performance evaluation can be measured based upon these different combinations. And so future research is needed for integration with emerging technologies as new technologies come up, and the caching mechanisms can be tested further with more open source caching databases. Thank you, everyone who has attended this session. I hope this adds value to you.